So now I have to design the patch. So for designing the patch, I will be activating the local coordinates which I will be getting on modeling. So I will activate on WCS, which is the local coordinates, and XYZ is the global coordinates. So if I use global coordinates basically, so it will, I have to calculate an equation, because on the top of the substrate I have to make, then I have to calculate from the origin, at how far from the origin I have to design the patch. So in order to check that, I have to click on this I have to check it is that this is the point of origin, and I have to make a patch on the top side of the substrate. So I have to write the thickness plus the thickness of patch, then only it will be here on, it will be on top of the substrate. But when I activate WCS local coordinates, then it will, the origin, whatever the point, at what point I have to design, and if I click the WCS over that point, it will take a origin from that center as well. So I will show you like this here. So since since patch has to be made on top of the substrate, so I will pick a face of substrate. So for that we'll click on F and double click on the top substrate, top surface, and we'll go on this section, and we'll click on align WCS with selected face, or you can directly click on this icon as well, which is align WCS. Now now my origin has been shifted to this point, which will help me in order to create a substrate directly from this plane. Now for patch, the plane will be the surface of the substrate, not the global coordinates. So this is the main advantage of the local coordinates. That's why it is said to be a local, because as per the design, or according to the design, we can change our origin or we can change our plane. Also, how I am rotating this design is with the help of control button plus left button of the mouse. So we'll hold the control button as well as the left button, and in whatever the way I need to rotate, it will be rotate. And in order to rotate in a clockwise in a vertical manner, we have to click on shift and then left button, and it will rotate in a Y plane. So we'll again click on on F5. So we'll get a front view of this. Now we have to design a patch. So again we'll go on to brick in the shapes menu, and then we'll click on escape, naming as a patch, and the dimension will be taking as a WP, which is nothing but the width of patch, and the length will be of LP with the LP by 2, and the and again the thickness of the patch is decided is nothing but the copper clad thickness. So here I will be denoting as TC. Remember that the copper cladding thickness, that is the copper cladding thickness on both the sides of dielectric, will be same only, it will not change. Now here I have to give a material as a copper, not a Rogers articulate. So I will write a copper and will go for annealed, because pure metal is not in the real world, again I will say, and that's why I will take the copper annealed and will click on load. And when I will click on preview, it will again ask for a dimension, and the dimension of width of patch is 4 mm, and again the length of patch will be 3.35, and the TC will be, that is the copper cladding thickness I have taken as a 0.017. So why I have taken the 0.017, what is the formula, and also basically the sheet which is available in the resource center which I have taken from. So in that they are having 0.017 or 0.035, so I have taken it as a 0.017 as well. So the next, it will look like this.